It's not over yet. The sunspots AR3697 and AR3664 are once again facing the Earth, preparing to unleash massive streams of plasma towards us. If these solar flares make contact with our planet, we could experience intense geomagnetic storms. Scientists have already sounded the alarm. In May 2024, we endured the most powerful solar storms in over 20 years, and the intensity is about to ramp up once more. The peak of the current solar cycle might bring us the strongest solar storm ever recorded. Did you catch the mesmerizing light shows over Europe in May 2024? The night sky transformed into a canvas of blood-red hues in some regions, while others were treated to green and blue auroras. These spectacular displays, typically reserved for the Earth's polar regions, were the result of a colossal solar storm. In the northern hemisphere, the glow reached far to the south, and in the southern hemisphere, the colorful lights danced far to the north. Prepare yourself for another cosmic spectacle as we brace for the next wave of solar activity. The entire Earth was affected by the effects of a stream of particles that was so violent that the safety mechanisms of our Earth's magnetic field failed. The electromagnetically charged particles penetrated the deep atmosphere and gave us more than just a fascinating glow. We were lucky this time. After the biggest storm in 201 years, only a few regional electricity suppliers reported problems or outages with the power grids. Elon Musk was relieved to post a diagram showing how well his satellites withstood the storm. This scenario could have turned out much differently. A solar storm the size of May's flare could have plunged us into a global crisis. Now the huge sunspots responsible for the storms are rearing up again. What will happen? AR3664 shows alarming activity on the surface of the Sun. Who would have thought that an X-flare with destructive proportions could brew within just a few weeks? Scientists observed the events on the Sun with concern, and even amateur astronomers could almost see the unbelievable with the naked eye. Within a few days, several smaller sunspots coalesced, and together formed a huge sunspot that was 15 times larger than our globe. On May 9, 2024, NOAA's GEOES-16 satellite detected a solar flare at 2200 hours our time. A huge stream of particles had broken away from the surface of the Sun and was heading in our direction. The source of the storm was clearly sunspot AR3664. Shortly afterward, the security systems issued a G4 geomagnetic storm warning. A G4 storm is classified as severe on the NOAA geomagnetic storm scale, and at worst, such a storm brings us outages in power grids and satellite technologies, disruptions in navigation systems and near-pole air traffic, and further disruptions in magnetic or electrical systems. The storm had just hit Earth when AR3664 released another stream of particles. On May 10, 2024, the satellites registered an intense solar flare of Class X 5.8. The spectacle began at 3:23 a.m. Central European Time, and the storm raged over the entire weekend, which once again brought us magnificent auroras, but also a number of problems in the power supplies. On May 11, 2024, geologists then recorded massive strain on the Earth's magnetic field for the first time. The charged particles from the Sun interacted so violently with the atmosphere that the magnetic field showed regional weaknesses and holes. We do not yet know what the long-term effects of such disturbances to the Earth's magnetic field will be. We can only hope and pray that our Earth will withstand the strain. No one knows exactly what could happen if our Earth's magnetic field fails. However, if there is permanent damage, we would certainly be exposed to a worrying increase in radiation. In the worst-case scenario, we could lose the Earth's atmosphere, which could have long-term consequences similar to those on Mars. It went on. May 14, 2024. The G5 storm scientists had seen it coming for many years. They'd been warning of the day when the G5 storm would put our civilization to the toughest test. On May 14, 2024, that time had come. The currently largest sunspot produced a solar flare of class X 8.7, which immediately went down in history as the largest of the current solar cycle. The solar flare would have had the makings of a G5 storm. Flares of this type result in massive coronal ejections, which hurl even more particle streams towards Earth. The consequences of this event on the Sun once again brought long-lasting geomagnetic storms to Earth. On May 27, 2024, it continued. Another powerful X-class solar flare was observed. This time, shortwave radio transmitters and receivers failed worldwide. International radio transmission, emergency communication systems, maritime and aviation radio, and military communication systems were affected. Ordinary people around the world were delighted to see auroras in regions where this phenomenon is not normally seen. The last geomagnetic storm in May 2024 was shown to affect the magnetic field down to the great ocean depths and had measurable effects on deep-sea compass systems, disrupting submarine communications, for example. International power companies reported regional problems in the power line systems, and a number of satellite operations were disrupted by the renewed violent solar storms. AR3664 becomes AR3697. What can we expect? Did you know that we can expect threatening emissions from the sun around the clock? Hardly anyone on Earth is aware of this danger. Sunspots occur all the time, and they don't have to be as big as AR3664 to cause us problems. Even smaller sunspots, which sometimes appear very quickly, can release huge flares. Sunspots are caused by intense magnetic activity on the surface of the sun. The sun consists of different layers, and the magnetic field is basically produced inside the sun. The magnetic layers themselves are created by the movement of electrically charged plasma inside the sun. When these magnetic fields break through the surface of the sun, they prevent hot plasma from rising from the interior, making affected areas cooler and darker. These are the sunspots that we can see with the naked but protected eye from Earth or with appropriate telescopes, depending on their size. Solar observatories, such as SOHO, monitor the sun around the clock. Every change on the surface is reported immediately, and scientists keep a constant eye on the sun's emissions. SOHO stands for Solar and Heliospheric Observatory, a static space probe that was jointly launched into orbit by the European Space Agency and NASA. Since December 1995, the satellite has been observing our sun at a distance of around 1.5 million km from Earth. SOHO is therefore in a very similar orbit to the new James Webb Space Telescope. On Earth, the largest solar observatory is located on the Haleakala volcano on the island of Maui in Hawaii. Solar observatories differ significantly from normal telescopes. Due to the direct view of the sun, they have to work with special filter technologies and be protected from constant solar radiation. In April 2024, the solar researchers in Hawaii and the experts in charge of the SOHO facility observed the formation of AR3664, a true giant among sunspots. At the rising peak of the solar cycle, the development of even larger and more interesting sunspots is normal, and yet this time, everything is different. For the first time since 2003, AR3664 bombarded the Earth with solar storms so violent that a permanent alarm was sounded. After its first flare-up, the spot traveled once around the blazing hot fireball along the sun's rotation axis. After a rotation period of 27 days, it returned. Then it pointed directly towards Earth again, and the researchers were warned once more. AR3664 had changed as it orbited the sun. Flare, or CME, which is more intense. It's hard to believe that there are areas on the sun that are up to 15 times larger than our Earth, and these areas are cold and dark. Sunspots are caused by completely normal processes inside the sun. Gases, plasma, and particles bubble in various onion-like layers. The magnetic field causes upheavals that we can hardly imagine, but millions of tons of seething hot material rise, sink, bubble, or cool abruptly. When magnetic field lines twist inside the layers, this creates a sunspot that is significantly darker than all other surrounding areas and also cooler. Due to the cooling and an effect that scientists call magnetic reconnection, enormous amounts of energy are suddenly released, and this phenomenon is known as solar flares or coronal mass ejections, CMAs, for short. The difference between flares and CMEs lies in the formation and the amount of material released. Solar flares are caused by the rapid release of energy, light, and high-energy particles from the twisted magnetic fields. CMEs, on the other hand, are huge bubbles of plasma and magnetic fields that are propelled into space by the sun's corona. When these bubbles hit the Earth, they can cause geomagnetic storms, just like flares, disrupting electrical systems, satellites, and navigation systems, and leading to intense auroras. Flares usually consist of less dense streams of particles, but they are faster and hit us in a few minutes or hours. CMEs transport more mass, but often take days to reach us. Threatening change. AR3664 becomes AR3697. It's not over yet. The sunspot AR3664 could have disintegrated, but instead of fading away, it has changed its shape and is now returning as AR3697. The spot, which has grown again, could continue to cause severe damage on Earth in the future. When AR3664 returned after 27 days of wandering around the sun, it underwent a dramatic change. Due to the streaking of many magnetic field lines, on its return, the spot was reclassified as AR3697, which is quite normal. Renaming after a lap around the sun is a common practice, and it helps researchers to continuously observe and analyze these phenomena. AR3697 continued its unusually intense activity immediately. On May 27, 2024, an X2.8 flare hit us, and just 1 week later, AR3697 hurled an X1.4 flare in our direction. These flares again brought us geomagnetic disturbances and shortwave radio system failures across the globe. The current solar cycle, known as Solar Cycle 25, began in December 2019 and is expected to last a full 11 years. We will not know what this solar cycle will bring us until we have passed the peak. We are only at the beginning of the most intense solar activity. The expected peak will be in 2025. If these many powerful flares were really just the harbingers, we must prepare ourselves for extreme stress. Click the subscribe button now. New exciting videos are coming all the time.